L'Hopital's rule, sometimes spelt as with a hospital, but it's pronounced L'Hopital. It's a silent S, uses derivatives to evaluate limits involving indeterminate forms. Does everybody remember from 40 pre-cal what indeterminate forms was? What was that? 0 over 0. Very good. Okay, so 0 over 0, we had, when we got it in limits, we did something else to evaluate the limits, right? So another indeterminate form is infinity over infinity, okay? So the rule is named after a French mathematician. Who's French here? Guillaume de L'Hopital? Guillaume. However, it's believed that the rule actually was discovered by Swiss mathematician Johann Bernoulli. So it's kind of like the debate of who discovered calculus, Newton or Leibniz. But anyways, so we're going to use L'Hopital's rule. Some people have already seen the term L'Hopital before on a meme somewhere. And so anyways, once you know this, you're going to go, why did you show me this one limits? It's because you didn't know what derivative it was. So anyways, and this actually only works when you have it as 0 over 0. So here's the thing. In the long answer section of the AP exam, they are so picky of how you have to write this. So you need to make sure, okay, it has to be written exactly like this or you will not get the marks for L'Hopital's rule. So if you have a limit and you end up getting 0 over 0 or infinity or negative infinity, then we can apply L'Hopital's rule. The College Board's very picky on how you write it, and it has to be shown as two separate limits, and then you state that you're using L'Hopital's rule. So what you end up doing is you state the set. So for instance, in the example coming up where we have cos x minus 1 over sine x, if I were to plug 0 in, does everybody understand that I get cos of 0 minus 1, which is 1 minus 1, which just gives you 0. And then sine of 0 gives me 0. I have a setup of a 0 over 0. So then you go, ding, 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 I can use L'Hopital's rule. So in order to use it, though, you have to state it this way. So the way you have to state it is the limit as x goes to 0 of cos of x minus 1, that equals 0. So you have to state them as separate limits, okay? And then the limit as x goes to 0 of sine x equals 0. Therefore, using L'Hopital's rule, the limit as x goes to 0 of cos x minus 1. It seems like a lot of writing, but that's what they want. Okay? So don't argue, just do it. So we've proved that we have a 0 over 0 setup by saying that above it. Now we're going to apply L'Hopital's rule. So what L'Hopital's rule says is if you have a 0 over 0 setup, you can actually find the derivative and then find the limit again, and you'll actually get the same answer. So okay, so using L'Hopital's rule, so this goes, now if you, we're going to keep going, right? So this equals the limit as x goes to 0. Now what's the derivative of cos x minus 1? Negative sine x. And then this is over cos x. Now if I plug it in, do I get 0 over 0 again? No, you get 0. If you happen to get 0 over 0 again, you're allowed to do it again, L'Hopital's rule. You can keep on going until it's done. Do you have to state that point? Yeah. Yeah. So if I plug this in, I get, what is negative sine of 0? 0. What is cos of 0? 1. So I get 0 as my answer. Okay, next question. If I plug 0 in right now, I get sine of 0, which is 0, 0 minus 0, 0 on top, and then 0 on the bottom. So I have a L'Hopital setup, but I have to do it separately. So if you want, you can say since and all this stuff. Sometimes that's nice to all tie it together. I'm going to write it with since. Since the limit as x goes to 0 of sine x minus x equals 0, and the limit as x goes to 0 of x cubed equals 0, using L'Hopital's rule. The limit as x goes to 0 of sine x minus x over, so you have to write it as two separate limits. That's the key here, okay? So, derivative? Oh, that should be an x, sorry. So then I get the limit as x goes to 0 of cos x subtract 1 over the limit as x goes to 0 of 3x squared. We got to do it again. I don't have enough room to do that. So, we're going to keep going. So for time's sake, we're not going to state it again. Like I said, on the exam, they've only done it that where you did L'Hopital's rule once. Okay, so then this would be the limit as x goes to 0 of, what's the derivative of cos x minus 1? Negative sine x over the limit as x goes to 0 of 6x. We still get it, right? So we're going to do it again. I know, that's why I'm saying this example, they would never ask on the exam. So the derivative of minus sine x is minus cos x over the limit as x goes to 0 of 6, because you still get 0 over 0. So now I plug it in, I get negative 1 over 6. That's my final answer. Okay, do you guys want to try, or do you remember the derivative of the inverse sine? Very good. That's very good. Okay, that's why you guys got your driver's license there. Okay, if I put this in, the inverse of 0 is 0, and you get 0, 0. Okay, so since the limit as x goes to 0 of x squared equals 0, and the limit as x goes to 0 of inverse x equals 0, using L'Hopital's rule, the limit as x goes to 0 of x squared over the limit as x goes to 0 of inverse sine x equals the limit x goes to 0. That would be 2x over, and what was this again? 1 over the square root of 1 minus x squared. Oh, I forgot my limit. Yeah, so if you plug it in right now, you get 0 divided by 1. Okay, so if I put pi over 2 in, I get secant of pi over 2 is, so we don't know, or so secant is the reciprocal of cos. Cos of pi over 2 is 0. If I reciprocate 0, I get 1 over 0. And so that's not 0. And then 1, it's undefined, right? So 1 plus tan x, tan of that is 1. Sorry, tan of pi over 2 is what?
1 over 0.
Yeah, so you can't even do L'Hopital's rule the way it's written. So then you're like, oh, okay, what do I do? What do I do here? So then this is just a limits question. What would you do if you put it in? You can't do anything.
Infinities, which way you ask?
No. You forget all your limits now. So then what was the process when you did limits and you got something goofy or whatever? You try to factor. If factoring didn't work, you tried conjugate. Trig identities. What do you think here?
No, isn't it square? In the trig identity, I think it's square. There's certain trig identities. No, I know it's over x.
Say that again. Sine x over x. What did I end up doing here, actually? I multiplied by, what did I do there?
Oh, because technically it's 1 over cosine sine over x.
We could try it as, yeah. What were you saying? Never mind. What were you trying to do there, Eric?
But there's no trig identity for them.
But you can change secant. Yeah, you could. It is squared. So yeah, let's try that. Okay. So let's just. I'm not gonna write it right beside. We're gonna try this without actually doing it as a limit. So secant would be 1 over cos x. I'm not doing this as a limit. I'm not writing it as a limit. I'm just seeing if I can get anywhere. Okay? So this would be 1 plus sine over cos x. Yes? Yes? Okay. So what do we do now? That's right. That's right. So 1 over cos x. And then I get cos x plus sine x over cos x. Yes? Keep change, flip. Keep change, flip. Can't cancel the cos x's. No. Okay, so then we get 1 over cos x plus sine x. And then does that work if we were to plug that in? So cos of pi over 2 is 0. Sine of pi over 2 is 1. Okay, so now we didn't have to, see, they'll do that to you. They'll throw stuff in, you think, oh, it's L'Hopital's rule because it's something goofy. Don't forget that you have all these other things in your back pocket. You can't just get trained, now I can use L'Hopital's rule for everything. It wasn't a L'Hopital's rule setup, right? So we get the limit as x goes to pi over 2 of 1 over cos x plus sine x. So what do we get here? 1 over 0 plus 1 gives me 1. Okay, next one. The limit as x goes to infinity of ln x. Think about the logarithmic graph. Oops, I'm doing that wrong. No, log graph looks like that. It's supposed to be going through 1. Anyways, so going to, when x goes to infinity, it's going to infinity, yes. Okay. So that is in the L'Hopital's setup, right? Infinity over infinity. Well, square root of infinity, it's not really a number you can, but really, if you put infinity in there, the whole thing goes to infinity, right? Yeah. So since the limit as x goes to infinity of ln x equals infinity, and the limit as x goes to, by the way, I've never seen an infinity over infinity on the AP exam. This is a new kind of way of them doing it. But, oh my gosh, no.
I didn't think so.
Okay, so just so you know, infinity isn't a number, so you can't perform function. It's not a constant.
It's a concept.
Oh, it's a concept. Yes, it's a concept. You can't actually perform functions on it, right? Like you can't go infinity divided by infinity like a variable and cancel and it's 1. That's what I'm saying. Okay, so 2 root x equals infinity. What do I usually say? Using L'Hopital's rule? Yeah. Therefore, using L'Hopital's rule, the limit as x goes to infinity of ln x over the limit as x goes to infinity of 2 root x is equal to the limit as x goes to infinity. And what's the derivative of ln x? 1 over x. Very good. over, and what is the derivative of 2 root x? Yeah, so I'm just going to write it like this so you can see what, you see that 1/2 times the 2 gives you 1, and then x to the power negative a half. So x to the power negative 1/2. Huh? Do you want to write it like that or 1 over the root? Okay. It doesn't really matter, but it does in a way. Well, you don't actually need to do that. So here's the thing. If you, the way it's written right now, what would you get when you plug it in? Yes. So if you put it in right now, you get 0 over 0. You can actually simplify this because they're both x's with the keep change flip. This is divide, right? So if I have x to the power negative 1 divided by x to the power negative a half, what would I get? This subtract this. No. Yeah, negative 1 half. Okay. So I'm going to simplify this. So this is the limit as x goes to infinity of, 1 over the square root of x. So that is what? 0. Okay.